My name is Christian Jallo. I'm doing kinetics problem from exam 2, problem 2A. And this material is covered in chapter 14.6 of the textbook on the Arrhenius equation. So in this problem, we are given that y equals negative 10,697x plus 26.561. This data suggests that collisional frequency, so we're looking for a collisional frequency, activation energy, the value of K, and we're given temperature. So the only equation that relates these three things is going to be the Arrhenius equation. The Arrhenius equation, as shown here, is ln K equals negative EA over R times 1 over T plus ln A. In this, we can equate y to ln K, m, which is negative 10,697, to negative EA over R, x to 1 over T, and 26.561 to ln A. And the Arrhenius equation relates temperature and activation energy to a rate constant. And those are the things we're looking for, and we're given temperature. In this equation, K is the rate constant for the reaction, EA is activation energy in kilojoules per moles. R is the universal gas constant, which is 8.314 joules per moles. Kelvin. T is temperature in Kelvin. And A is a collisional frequency factor, which is unitless and essentially expresses the probability of the orientation of a molecule and is specific to the reaction you're doing. So, as we said, we can say that ln A is equal to 26.561. From this, to undo the natural log, we do everything to the power of E. So A goes from ln A to just A, and now we're saying that it's equal to E to 26.561. Once you solve this, you simply get that A is equal to 3.43 times 10 to the 11th. Next, we can say that negative E over A over R is equal to 10,697. But in this case, R is times 10 to the negative third. Now, why is that? That's because we're working in kilojoules instead of joules. So the universal gas constant, instead of being 8.314, an easy switch from joules to kilojoules is to just make it times 10 to the negative third. So to undo this to get EA by itself, we're going to put the negative into the gas constant and multiply both sides by negative 8.314 times 10 to the negative third. So this problem is just multiplication, and you get 88.9 as your answer. Moving on, we're looking for K. So we can just plug in K for Y in the original equation. So you have ln K equals negative 10,697 times 1 over T, we said was X. And in this case, T is 77. But because we need to do this in Kelvin, we add 273. And then, of course, you put in the extra 26.561. You can just do the arithmetic. You do out all the numbers, and you get ln K equals negative 4.0019. Just like we did with A, you raise everything to the E, so ln K goes to just K. And on the other side, you get E to the 4.0019. Now you just solve, and you get K equals 1.83 times 10 to the negative 2 second, 1 over seconds. So you seconds to the negative 1. So we can say that A is unitless because it is just a collisional frequency factor. We have EA, activation energy, in kilojoules per mole, and we have K in 1 over seconds. We can see here, once again, we just simply took this equation and equated ln A to 26.561, this n part, 1 over T to X, here in K, in figuring out L and K, which we equated to Y, and negative E over A over R being B. And so this is how you can solve the Arrhenius equation given a Y equals mxb and a temperature.